Now let's do further sum based on the GP. If A, B, C, D are in GP, then show that A plus B, B plus C and C plus D are also in GP. Now here if we recollect the basic definition of GP, it is a sequence in which the ratio of consecutive terms is constant. So if the four terms A, B, C and D are given to be in GP, we can definitely write the ratio of B by A to be same as the ratio of C by B, which in turn is equal to the ratio D by C. Now for the sake of simplicity, we can assume each ratio to be equal to say some constant K. Alright, so this gives us B to be equal to A into K by cross multiplication. Then C is nothing but B into K, but we have already found that B is equal to AK, so therefore putting the value of B here, we will get C to be equal to nothing but AK square. Similarly for D, we have basically CK, but putting the value of C, which we got as AK square, we get D to be equal to AK cube. Right. Now we have to show that the three terms A plus B, B plus C and C plus D are in GP. So that means what we have to basically show is the ratio of B plus C to A plus B should be equal to the ratio of C plus D is to B plus C. So that means by cross multiplying, we have to finally show that A plus B into C plus D is equal to B plus C the whole square. So if we show this, then it will prove that the three given terms are in GP. Alright. So now let's start with LHS. LHS is A plus B into C plus D. Now let us substitute with the values that we have got. A is same, B is nothing but AK, right? Then C we found to be AK square and D is nothing but AK cube. Now from the first bracket we can take A common and we are left with 1 plus K. And from second bracket, if you observe, we can take AK square common, right? And then in the bracket we are once again left with 1 plus K. So if we club the terms, we have A into A square multiplied with K square, and here 1 plus K also occurs 2 times, so we have 1 plus K the whole square. Now if we look at the RHS that we have to prove, it is the square of B plus C. That means we have to somehow arrange the square of some expression. And here whatever we have got, we can see that each term is a square term. So therefore we can definitely write this expression as A into K into 1 plus K the whole squared. So we have arranged the square on right hand side. So the only last step is to somehow get B plus C. And we know that B is AK and C is AK square. So it's clear that when we do the multiplication inside the square bracket, we will get AK plus AK square the whole square, and hence finally AK is nothing but B and AK square is nothing but C. So we get B plus C the whole square, which is RHS. So therefore it's proved that A plus B, B plus C and C plus D are also in GP. Let's move ahead and see another variety of question where we have to find the sum of this particular interesting series, that is 3 plus 33 plus 333 and so on up to n terms, right? Now here to solve this type of question, whether it's the digit 3 that is repeated or whether it is 4, 5 or 6, it might be any digit. Okay. There is a same procedure, that is what do we do is first we convert this into the series of ones, right? Then we convert that into the series of all the 9s, right? And then based on this, we somehow arrange a GP and then write the formula for sum of the GP. Alright, so this is the overall scheme of reasoning. Alright, so now let us do that one by one. So let us see how to achieve that first. Now if you look at the given series, it is all 3's, and as we have seen, first of all we have to arrange or adjust all 1's. So that means if we take 3 common from all the terms, we will definitely get 1 plus 11 plus 111 plus 1111 and so on up to n terms. Alright, so we have achieved the first step, that is we have got all the 1's. Now next what we have to do is we have to somehow write all the 9's, but we cannot just write as it is because we will have to then adjust the 9 in the denominator also. So if we multiply all the terms in the bracket by 9, we will have to also outside divide by 9. So multiplying and dividing by 9, we get inside the bracket 9 plus 99 plus 999 and so on up to n terms. So there are n terms. So here we have, I will still keep 3 upon 9 as it is to show the generalization at the end. Right. Now this 9 which we have obtained is going to be a very fruitful step, because 9 can be written as 10 minus 1 plus 99 can be written as 100 minus 1. So you see, each of this term can be written as a power of 10 minus 1. So on up to n terms. Now here what do we do is, we have 3 by 9 into bracket. Let us collect all the powers of 10 in one bracket. So we will have 10 plus 100 I can write as 10 square plus 1000 is nothing but 10 cube and so on. Since we have n terms, the last power will be 10 raised to n, right? And from that minus, if you look at the remaining minus 1's, okay, there will be minus 1 occurring n times. So therefore that will be nothing but minus n, right? Now next, the remaining part is, if you look at the bracket, here this is nothing but a GP in which the starting term is 10 and the common ratio is 10 again. So therefore we know the formula of sum of n terms of a GP, which is nothing but the first term multiplied by the common ratio raised to number of terms, that is n, minus 1 whole upon common ratio minus 1, and minus n we have here. So therefore that turns out to 3 upon 9. Here you have 10 into 10 raised to n minus 1. Now 10 minus 1 in the denominator becomes 9. So when you club that in the numerator, you get 9n whole divided by 9. So which finally gives us, we can merge the two denominators and we have 3 upon 81 into bracket 10 into 10 raised to n minus 1 minus 9n. So this is the required sum. Now if you remember, I said earlier that let us not cancel 3 with 9. Here we see the reason why. That is, if we have the given question which consists of all the 3's, then the final answer will have 3 in the numerator and entire rest of the expression remains unchanged. Alright. So if it were to find the sum of say 5 plus 55 plus 555 and so on, the only difference will be that this first digit will become 5 but rest of the expression will remain exactly same as it appears here. So therefore this is the final answer.